Okay, this last little part is just going over some other ways we can think about a lot of things. So, what we can see here is that a ratio is a way to compare amounts of quantities or describe relationships between two amounts, and ratios have the same units. Basically, ratio is a fancy way to say a simplified, oh my God, that's a terrible do, a simplified fraction. Okay. So we've already been dealing with ratios a bunch. Rates are a special type of ratio to describe the relationship between different units, like miles per hour, which we're going to get to in later classes. But ratios have the same units. We're comparing people to people, milliliters to milliliters, puppies to puppies, whatever it may be. So if we come down here for our examples, in a box of syringes, there are 10 small and 20 large. What is the ratio of small to large? 2 is our key word here of what's going to go, whatever comes before the 2 goes into your numerator. Whatever comes after that is going to go into the denominator. Okay. So if we're to want the ratio of small to large, I need small in my numerator, I need large in my denominator. And now I can simplify. I can divide both of these by 10 because they both end in 0. And I get there's a ratio of 1/2. And what this means is that if this is 1 small on top and 2 large on the bottom, for every 1 small syringe we have 2 large syringes. It's a comparison of the quantities. So if we had 10 over 20, that reduces to we have 1 small for every 2 large we have. We know the comparison. So Karina spent 4 hours studying biology and 1.4 hours studying math. What is the ratio of studying math to biology? So I want math on top of my fraction because that came before the 2 over to biology would be my 4. So it doesn't matter what the order of the problems are. This 2 is going to let you know what the ratio is, where 2 is kind of like your fraction. So math to biology. To simplify this, we are not allowed to have decimals inside of our ratios and our fractions. So I need to move this decimal over once, which means I need to move this decimal over once. So this will be the same as 15 over 40. And now I can start simplifying from here. Anything that ends in 5 and 0, both numbers can be divisible by 5. 15 divided by 5 is 3. 40 divided by 5 is 8. And remember, my top was math. My biology was the denominator. So this means for every 3 hours that they study for math, they study for biology for 8 hours. And obviously 1.5 is half of 3. But if we had the ratio the same, if she did 1.5 for math, that's why she did 4 hours for biology, because it's a ratio of 3 to 8. C, there are only 9 dosages of an antibiotic for every 10 patients that need the dosage. Write this as a rate. What % of patients are receiving the antibiotic? I think this is still needs to be a ratio. I think this is a mistake. And then we can figure out the % of patients receiving the antibiotic. So there were 9 doses of antibiotic for every 10 patients. That's already simplified. So now we can decide what % of patients are receiving it. 9 divided by 10. 10 can go in 9 times. So we get 0.9 as a decimal. As a %, that is 90% of the patients then can receive their antibiotic. Last section, this should be 3.3. A true proportion is an equation that states that 2 ratios are equal. which is a fancy way to say two fractions are equal. So in order for a proportion to be true, they should be the same fraction. So that means if we could either reduce this side down to see if we would get 2/5, and we can compare fractions. We could divide both of these into a decimal and see if we get the same decimal. But a really quick and easy way to know if two proportions are, if it's a true proportion, which means we have equal ratios, we have equivalent fractions on both sides, we can cross multiply and see if they're equal. 5 times 10, so I'm going to make an X so I know what I'm multiplying. 10 times 5 is 50. 2 times 40 is 80. Those are not equal, which means this is not a true proportion. Those are not equivalent fractions, which I can also show by simplifying 10 over 40. If I divide both sides here by 10, 10 divided by 10 is 1, 40 divided by 10 is 4. Is 1 over 4 equal to 2/5? No. So that's another way we could have checked if this was a true proportion. Both fractions must simplify down to the same simplified fraction if it was true. But this cross multiplication can let you know if it's possible or not. So if we do that over here, I'm going to make my X so I know when I'm multiplying. 84 times 10 is 840. Anytime we multiply something by 10, we add a 0. And now 21 times 40. 1 times 0 is 0, times 4. I need to put in my placeholder now. 2 times 0 is 0, 2 times 4 is 8, and we end up getting 840. So this means since when I cross multiply, they're equal, this is a true proportion, which means if I wanted to, I could take both of these fractions and simplify them down to be the same fraction, which I'm going to go ahead and show you now because I have time. So if I took this, I see both of these are even, and I know that 84 is also divisible by 4, and 40 is. So I'm going to divide both of these by 4. 40 divided by 4 is 10. 84 divided by 4 is 21. And look at that. That already reduced to the same fraction over here. So that's another way you can check. But this cross multiplication told me I knew that I was going to be able to do that. So to solve a proportion, that just means one of the fractions is unknown. We don't know what's going on there. So to solve a proportion, we can cross multiply and solve for our unknown amount. So I can cross multiply. 12 times x is 12x. Because I assume there's a 1 out front. 12 times 1 is that 12. Now 27 times 20 times 0 times 0, placeholder of 0. 2 times 7 is 14. 2 times 2 is 4 plus 5. So I end up getting 540 right there. So 27 times 20 is 540. 12 times that 1 with x gave me 12x. And now we're going to continue using our inverse operations. I know that 12x is the same thing as 12 times some number x. This stands for multiplication. So if 12 is being multiplied by x, we have to do the opposite, which is dividing. Anything divided by itself is 1, so we're left with just x. And now we need to do 540 divided by 12, which I'm going to do over here. Just because I'm running out of space. 540 divided by 12. I know 12 times 4 is 48. We can borrow to get 60. I know 12 times 5 is 60. So over here I get x is equal to 45. Because 540 divided by 12 came down to an even 45. And the same thing will be true for the next one. We will cross multiply and divide.